Hello everyone. In this video, I am going to explain what is an algebraic terms and how to create a new algebraic terms from the old ones. So please watch this video to the end so that you won't miss this important information. As we know, algebra is an area in mathematics that traditionally well known for using alphabets and symbol to represent various numbers. And we are going to use the ending part of the alphabets, that is, for example, X, Y, and Z to represent variables. And we are going to use the beginning part of the alphabets, namely alphabet like A, B, C to represent what we call coefficient. Alright? But this is not always true because sometimes we also use variable like P, Q, R, and alphabet to represent variables also. In general, an algebraic terms can be written like this: A multiplied by X, okay, where this symbol A is the coefficient, and the symbol X is for the variable. Okay, for example, we have 2 times Y, like this, 2Y, okay. This number 2 is the coefficient. Okay, and this alphabet Y is the variable. Another example we can give, for example, like this, 3W. This is also an algebraic terms. Must consist 2 components, that is, must have a coefficient and also a variable. So in this case, 3. Yeah, the number 3 is the coefficient, and this symbol W will be the variable. Another example, maybe we can give something like this, 20Z, like that. 20Z is also an algebraic terms, where 20, okay, this number 20 is the coefficient, and this symbol Z is the variable. Now suppose that we are given something like this, and we want to decide whether this is an algebraic terms or not. Negative 3W. Yeah, the answer is yes, because we have the coefficient negative 3 and we have the variable W, right? Now, how about Y over 2? Is this an algebraic terms? Yeah, the answer is yes, because the coefficient is 1 over 2 and the variable is Y, correct? Now let's give one more. For example, we have 4.5x. 4.5x. Is this an algebraic terms? The answer is yes, because this number 4.5 is the coefficient and this symbol X will be the variable. So the number for coefficient can be any real number. In fact, we can have something like this, square root 2y. Okay, this is still an algebraic terms because the coefficient is a real number, that is square root 2, and the variable is y. Now suppose that we have something like this, 6x squared, which means 6 times x times x. Now, is this an algebraic terms? The answer is yes, but this time we are having, the variable having power 2. Okay, you can have something like this also, and 6x squared, the terms like this is also can be considered as an algebraic term. The coefficient is 6, this is the coefficient, and the variable is x. Let's give another example. Things like this: 7. We have y cubed, for example, which means that 7 multiplied by y, multiplied by y, multiplied by y. You know, this dot sign is just represent multiplication. Oh yes, so 7y cubed is also another example of an algebraic terms. How about, when the power is negative, something like this: 8w to the power negative 2. Yeah, this is also another example of an algebraic terms. Okay, 8w to the power negative 2 means 8 over w square, which also means 8 over w multiplied by w. Yeah, w multiplied by itself twice, 2 times. Okay, therefore 8w to the power negative 2 is also another example of an algebraic terms. Now suppose that we have these two algebraic terms, that is 3y and 2x. Let's multiply them together to produce a new algebraic terms, that is doing this, that is 3y times 2x will be equal to, let's multiply the coefficient 3 and 2 together. 3 times 2 is 6, and y times x is yx. And usually we write the variable according to alphabetical order. So that will be 6xy, like that. Alright, this is the new algebraic terms that we get after we multiply 3y and 2x together. We have 6xy. Okay, please take note that these new algebraic terms having two variables. We have two variables this time. There is x and y. Okay, in fact we can have more than two variables in one algebraic terms. For example, if we multiply, algebraic terms 4w multiply with maybe 2x, maybe with 3z, for example, 4w multiply by 2x and multiply also by 3z. What do we get? Now let's multiply the coefficient first. 4 times 2 is 8. 8 times 3 is 24, right? So we have 24. And the variable will be w. Another one will be x. And another one will be z. This is a new algebraic terms having 3 variables. That is w, x, and z. Now this time, let's suppose that we have two algebraic terms, that is 5z and also 10w. Alright, now I want to multiply 5z to itself. What I mean is, I want to multiply 5z multiplied by 5z. Okay, again, as we did before, we have to multiply the coefficient. That is, in this case, 5 multiplied by 5 will be 25. And z times z is equal to what? Yeah, z times z is equal to z square. So we have 25z square. Okay, this will be a new algebraic terms. After we multiply 5z with itself, 5z times 5z equal to 25z square, a new algebraic terms. Now, how about if we divide, these two algebraic terms? That is, maybe we do this, 10w, let's divide by 5z. Alright, now 10 divided by 5, we get 2. We have 2w over z, right? Or we can write like this, 2w z to the power negative 1. Okay, now this is a new algebraic terms that we get by dividing 10w divided by 5z. Okay, having variable w and also z. Okay, again, I want to stress here that we can get a new algebraic terms by, okay, by using division, okay, the operation division also, okay, besides using multiplication. This one is multiplication, multiply, this one is we do divide or divide out, or we do it division. Let's say we have these two algebraic terms, that is 2p and 5q square. We want to divide them together to produce a new algebraic terms. That is, let's divide 2p divided by 5q square. Okay, this will be equal to 2 over 5, okay, p, and then we have q to the power negative 2. All right, this is another algebraic terms having two variables, that is p and q. So in this video we have talked about algebraic terms. All right, the definition of an algebraic terms must have coefficient in terms of coefficient a, and also must have variable x. Okay, maybe more than one variables, maybe we have two variables. For example, we have a coefficient x, maybe we have a variable x also, maybe we have variable y also having two variables, or maybe we can have more than two variables. All right, something like this. A, that is the coefficient, maybe we have x, maybe we have also y there, and maybe we have z. So that would be an algebraic terms with three variables. All right, and we also been talking about how to create a new algebraic terms by using multiplication, multiply, and also we can divide. We can divide two algebraic terms to produce a new algebraic terms. Okay, that's all for now. We'll see you next time.